modulating voltage. So in amplitude modulation, it is the amplitude of the carrier which is varied by their modulating information or their modulating voltage. And your carrier voltage is made proportional to the instantaneous modulating signal. That's why it is dependent now that your modulating signal turns to vary one of the property of your carrier, which is the amplitude. So here is a typical block diagram ng AM modulator or amplitude modulation technology, wherein your AM modulator is the technological part of your amplitude modulation. So you're modulating signal as your VM voltage, VM, and then your carrier voltage join into your AM modulator to output yun yung amplitude modulation as an output signal. So here is an illustration of your amplitude modulation as a result. So ito, with the lower frequency, ito yung modulating signal, and then your carrier frequency, ito naman, with a higher frequency. As a result, ito yung sa amplitude modulation. So we will try to trace it back later, pero if we take the peaks of all the amplitudes and draw, or the broken line you can see is called the envelope. Okay, the general equation for the amplitude wave, amplitude modulation wave. So the carrier voltage is represented, ayan, BC sine of your omega CT, wherein your omega CT is 2 pi times your frequency, 2 pi f. This is in time as a function of time and the or instantaneous equation for the carrier voltage, and even for the modulating voltage. So Vm naman sine of omega m times your time. The amplitude resulting from this modulation is denoted as A. So we have the sum of your carrier at the same time of your modulating signal Vm. And since now we know that MA is now the ratio of your modulating voltage over your modulating, your carrier voltage. So we can substitute it with the amplitude resulting from that modulation. That Vm is equal to Vc times MA. Then we'll derive with the voltage of the resulting AM as wave envelope at any instant as your amplitude sine omega c of t, your amplitude modulation. Or in a general form, ito siya, pwedeng through your VC, carrier voltage, times 1 plus your MA. M is your modulating index. Modulating index for a amplitude modulation. Sine omega mt times sine omega of your C, T. Or standard form wherein it will represent now yung pinaka-output, wherein kapag i-describe naman natin siya into frequency spectrum, pakikita natin doon yung carrier, your lower sideband, and your upper sideband frequencies. And omega m and omega c, 2 pi c, 2 pi fm. And frequency ng carrier and frequency of the modulating signal. Always take note kapag sa carrier, mas mataas yan lagi dun sa modulating signal frequency. P to represent now instantaneous time. MA, the modulation index, wherein modulation index, and nga, it is a ratio of your voltage, modulating voltage over your carrier voltage. Agad example tayo, a carrier with an RMS voltage of 2 volts and a frequency of 1.5 megahertz, modulated by a sine wave with the frequency of 500 Hz and amplitude of 1 volts RMS. Write the equation for the resulting signal. Ito pwede agad na parang pinaka-question agad sa analog communication. Pwede yung equation mismo ng resulting signal. So we have a carrier with 2 volts RMS, frequency of 1.5, modulated, so we're referring now to the modulating signal of 500 Hz and amplitude of the modulating voltage of 1 volts RMS. Write the equation for the resulting signal. Try. Kasi pag ganito, most of the time, hindi na ako basta magsusolve. Kayo dapat. Aris, wala ka ti ballpen mo, nakon papelhan nga, titigam lang man di slide. Oh. Kailangan iganam lang ta ballpen, anati calculator. O, iganam lang. Ang solve ka kasi review na nga to, expected dapat alam nyo na pag nakita niya, oo, ganun nga pala yun, ganun. Kasi nga dagos, ganun dapat yung practice dito, nga titigam lang. Ano pa na look spam to na board exam. Ano nga mabalin nga kasdya. Kailangan kasi siya. Asher, andyan ka? Oy, Buwan, Mr. Buwan. Markaida, yung mga camera nyo on. Nag-turn off kayo mag-turn camera ngayon. Raddan. Solve nyo agad yung 2 pi f, 2 pi f, yung mga omega c, omega n. 2 pi f c, 2 pi f n. So, substitute ko naman yung voltage. Pero take note, given in RMS yan May nakuha na ba? Ano dapat dito, guys? Na Haris, ito na solve mo?
Wala pa, sir.
Apa yung awan? Ipakita di formula niya. Ubra, solve lang na niya. Direct, padagitan niya.
Sir, pag ganito anong form? General or yung standard? Hindi nakalagay.
Mas maganda kahit i-general nyo na lang. Or, in general na lang. Dapat general dyan. These stages, mas mapapansin mo naman choices. So, first, since RMS will be convert na siya to peak value. So, just multiply with the given voltages kanina. By then, so ayan. So, yung mega set and mega F, 2 by FC, 2 by F lang. And then, the equation or general formula. So, substitute direct solution under your DC or your AC, and then inside of your mega MED, inside of your mega CP. Ganyan yan lang. Wala lahat. Dali-dali lang naman yan. So, susunod na ito, domain standard yung kita na ngayon. Or representation, you will be able to see your upper side and lower side. And then the center is yung sa carry or graph relative actually signal gains your frequency for the time domain standard AM. So ito ay right place. So ayan, this is the result of AC amplitude modulation. So saan natin makikita dyan yung carrier voltages and then your modulating signal ayun siya, we try to consider yung may dun sa may envelope. So with your modulate index, multiply your carrier voltage, that is your that shift that your carrier, yung constitute your modulating signal voltage, and then same mo dito yung sa pagbaba. And this is a modulated, and this is modulated with the trace of peaks, amplitude, voltage, and envelope. Okay, the curve goes by joining the keeps the individual major frequency cycles of the forward and envelope. More on your modulation index. So while back already note the duration that is your modulate voltage over your carrier voltage, or other pag-determinate natin ulit, we can calculate by yung modulation index as Vmax minus your Vb over Vmax plus Vb. Kasi ang modulation index ng values niya is from 0 to 1. 0 to 1. 1. And ideal sinabi namin ng modulation index, the degree of modulation or modulation coefficient, the depth of modulation, or amplitude modulation, dapat ay ideal. Perfect.
Paano sir?
1. About greater. Pag sa 1, baga dito sa part ito, kita nyo na yung that is 1. Pag dito sa part greater than 1, nangyari kasi nag-overlap. If you have the power, parang magkakaroon ng difference or nagkakaroon ng cross-polar message. Pwede mangyari mag-cross-polar yung analysis sa ideal na nasasakot ko. Perfect modulation. Hindi dahil sabi din siya na hindi na over-modulated. Also, your VMPC can also be calculated with Vmax minus Vb over 2 or your VCC Vmax plus Vb over 2. And since we use the derivation of modulation. About percent of modulation, express natin siya in percentage. So your modulation index times 100%. So ito given ito, pwede ding waveform yung ibigay, pero most of the time hindi naman na kasi ma-effort ito eh. Calculate the modulation index of the given waveform. Ayan. Alam nyo ba magbasa kapag sa oscilloscope? Don't worry, lagpasan na natin to, hindi na expected, wala ganito sa mga board exam. Kahit ako hindi ako magbibigay. Pero alam nyo magbasa ngayon ng kapag dun sa, baka later on bigla naman mayroong ibigay. Magbasa ng results from the oscilloscope or ito, in time domain, wherein the vertical is 25 millivolts per division and then the horizontal is 200 microseconds per division. Modulation index lang naman yung kailangan natin dito. So sa modulation index, ayan lang din yung Vmax minus Vmin over your Vmax plus Vmin. So kailangan nyo lang i-consider dito yung Vmax and then your Vmin. Ano ba daw? Peak to peak or peak only? Pag ganito, ano dapat? Is it peak only or the peak to peak? It's easiest to use yung peak to peak values with the oscilloscope. From the figure we can see ayan. Ano yung Emax? So pag peak to peak yung ginagamit natin. Peak to peak. We know that the vertical 25 millivolts. O peak to peak. Ayun.
75,
peak to
sir.
peak. Peak to peak. So yung ginamit mo is yung peak. Tama? Pero pag nag-peak to peak tayo, that's 100 millivolts. Tama? Volts peak to peak. Mas maganda yung peak to peak kahit yun din yung gamitin mo mas maganda. Kasi minsan pwede that your center or your y-axis or your time domain axis minsan is hindi nakasentro. Pwede din ganun kasi shifted, kumbaga. It's safer to use peak-to-peak na values. So your Emax is 150, tama? Times 2 lang yung kinuha ni Asher, and then your Emin. Let's say it is at the center on this second interval. So 25, 25, tapos buuin mo na lang din yun. Ilan? Yung Emin naman, ano?
75 millivolts.
75 millivolts. That is also peak to peak. Disregard ito, should be 75. So your modulation index, so Emax 150 minus 75 over 225. So ilan? That's supposed to be 75. So as a result, it's 33.33. Ito kasi, pero very obvious naman na parang gagamitin mo yung center. Ito lang kasi dun sa book. Anyway, that's supposed to be 75. Pero sabi ko nga, just so you know paano naman mag given yan, my goal naman dito is for you to know how to read. Iwasan lang din natin baka later on lumabas mga ganitong type. Hindi nyo alam. Okay, next. In the frequency domain, so paano ba natin ini-illustrate or napakita yung sa may upper sideband and lower sideband? So from the carrier, that's just simply plus and minus of your modulating frequency. Pag voltages naman ng lower sideband and upper sideband, so your modulation index times your carrier voltage divided by 2. Simple as that. So titignan nyo dito yung sa length of the arrow, so most likely half of it is your upper sideband and lower sideband on the voltage. Degrees of modulation, so the perfect modulation nga is at 1, modulation index is 1 or at 100%. So ganito itsura. Kapag under modulation, so yun, magkalayo yung gap of your mga V-min, and then pag over modulation, there is an overlapping nga. It could cause now loss into the message. Our sample problem, a modulated wave has a peak value of 2 volts. So give niya ang binigay is the peak value. The carrier wave equation for the voltage 1.2 times your 20t plus t. Determine whether the signal is over modulated or not. So ano yung given? So we have a given carrier wave. O so ano yung 1.2? Ano ngayon yung 20t plus 15? Ano yung sa 2 volts? Modulated wave. So given yung VM, modulated wave. Sa peak value of 2 volts. The carrier wave. So 1.2. Yun na yung amplitude naman ni carrier wave. The 1.2. How do we calculate now the modulation index? How will we determine it's overmodulated? Pag overmodulated, that is greater than 1. I know, given na siya agad, Vm over your Vc, which is 2 over 1.2. Sa result, we have 1.67, meaning it is overmodulated. Pero hindi lang yan yung analysis when it comes to the amplitude modulation or even sa technology as a measurement. So, meron din dapat power relationship, and you should understand power relationship measures. So the power that is the most important, however, is not the total signal power, but only the portion that is used to transmit information. Since the carrier in an amplitude signal remains unchanged with modulation, it contains no information. And it is the sideband that carries the information. Its only function is to aid in demodulating the signal at the receiver. Para nga mas alam ngayon ni mga receiver technologies kung ano yung content. So it is the sideband that carries the information and not your carrier. So yung carrier ginagamit lang para mas ma-distinguish yung message. So AM inherently wasteful of power compared with some other modulation scheme. That's why meron tayong mga single sideband techniques and other techniques used in the system technologies. So power relationship, the power in the carrier is easy to calculate since the carrier by itself is a sine wave. So the carrier is given by the equation. So from that general equation representing now your carrier wave. So with the peak voltage ng carrier sine of your omega c is 2 pi fc. This is the picture of the power developed when the signal appears across a resistance R is simply, so pag given tayo ng resistance, syempre isipin mo na din sa technology, so paano natin i-measure, simply power of the carrier is yung DC squared over your R, DC squared over 2R. The power inside naman para natin yung power inside given yung power relationship sa carrier. So yan, it's expected that equal to my process like the resistance and linear modulation takes to like yung PCC over 2 since the carrier and sideband are part the same signal even a resistance R as the carrier. So your sideband power is calculated. Ito, sorry. So ito, your lower sideband and upper sideband. Paano pag yung total sideband? So times 2 ito, kaya over 2. M squared over 2 times your PC. Kung baga yung total sideband yung mini-measure, just simply times 2. So the upper sideband and the lower sideband taken as 1. So mga sideband power, so M squared over 2 times your power of the carrier. Next, these two sidebands have equal power, the total sideband power over 2. Total power in whole signal is just the sum of the power in the carrier and the sideband. So as a result, doon sa modulation, amplitude modulation, as a result, so combined yung two powers. So this is the derived. It is your PC times 1 plus M squared over 2 for the total power. So yung pag total power kino-consider natin, ito na yung modulated na wave. Ito na yung result ni amplitude modulation since. So it is the amplitude modulated wave. Please be observant kung paano niya mini-mention later on sa mga problems. So those were the derived. So PC is constant value before and after modulation. PT is the total power after modulation. So after modulation. Before modulation is PC. Dependent on the modulation index. The higher the modulation index, the higher the output of the power. Ganon naman. Minsan no to analyze also formulas kasi pwedeng dun lang mag-revolve yung mga question. Since it is directly nasa above naman, nasa numerator part. So it is really dependent now dun sa value also ng modulation index. So the higher the modulation index, the higher the power. Some important things with regards to the total power in an AM signal, with modulation reaching a value of 50% greater than of the unmodulated carrier for 100% modulation. The extra power with modulation goes into the sidebands. The carrier power does not change with modulation. So the useful power, that is the power that carries information, is rather small, being a maximum of 1/3 of the total signal power for 100% modulation and much less at lower modulation indices. For this reason, yung AM transmission is more efficient when yung modulation index is as close as 1 as practicable, or yun nga kasi yung idea. Another problem. So a transmitter supplies 8 kilowatts to the antenna when unmodulated. So it says unmodulated. So that is your PC. And then determine the total power radiated when modulated to 30%. Okay, they solve. Ang result lang. Okay, na-solve na. Guys, PC times 1 plus M squared over 2. Nag-lock ka. Ano ba yan? Sagot.
Sir, 8.36 kilowatt.
8.36 kilowatts. So, nakuha lahat. Okay, since may power na tayo na calculation, so pwede natin i-relate ngayon to sa current and voltages. So, when you derive, so ano ba? At a given constant R lang naman kapag i-derive mo siya, given this formula for the power. So, paano magiging formula? Ay, yun. So, given R, magkakaroon ng square root kasi nga, ano yung calculation ngayon? At the same, and V squared R or the I squared over R. Okay, when calculating given naman yung mga current and voltages of the carrier and the total power or the amplitude modulated wave. So, ayan. Total current IC times square root of 1 plus M squared over 2. Ganun din sa V. VC times square root of 1 plus M squared over 2. Apply agad natin. The antenna current of an AM transmitter is 8 ampere when only the carrier is sent, but it increases to 8.93 when the carrier is sinusoidally modulated. Find the percentage modulation. Ayan, ganyan yung sa pag-term. Sa antenna current, ano yung 8 amperes, ano naman po yung 8.93. When the carrier is sent, but it increases to 8.93 when the carrier is modulated. Sabi yung ganun. So, your 8.93 is the resulting current kapag nagkaroon na ng amplitude modulation, wherein yung 8 is kapag unmodulated pa siya. And that is for your carrier. So that is your IC. And then IT naman si 8.93. Kuha, find the percentage modulation. Oh, shift solve, Medagos. We have 8.93 equals now to IC8 square root of 1 plus alpha x squared over 2.
70,
solve.
sir.
70%.
0.70 or
70.
kapag percentage modulation, so times 100, that is 70.1.
70.1.
How about kapag multiple stages or so mayroon tayong simultaneous modulation by several carriers? So paano po natin sinusunod? So guys, given now several carriers, so the calculation and pag multiple for voltage, the modulated voltage, as a result na the total modulating voltage, square root RMS para pagkuha. So square root, the sum of the squares of the square root of the sum of the squares of your B's and then your I's and even sa mga modulating index. Effective total modulation index, the total modulated voltage, total modulated current. Next, find the modulation index if a 10-volt carrier is amplitude modulated by 3 different frequencies with amplitudes 1, 2, and 3. So, given tayo ng 3 modulation indices, 1, 2, and 3. So, ayun, sa calculation, ganun lang. Modulation index, if a 10-volt carrier is amplitude modulated by 3 different frequencies with amplitudes 1, 2, and 3. Ano po yung modulation index? since we have 3 different frequencies given. Let's take note dun sa given So we have a volt carrier, the peak voltage of 10, 3 different frequencies pa, modulated. So we have 3 VM. VC yung given or your EC. Tapos we have your EM or your VM. So take it 1/10, 2/10, and 3/10. Kumbaga yun yung mga modulation indices. And then take the RMS of the sum of the squares. And 0.374. Dali pa lang naman. Naguha, nakuha. Proceed tayo, proceed. Hello, hello. Hello, hello. Next, 360 watts carrier is simultaneously modulated by 2 audio waves with modulation percentage of 55 and 65. Respectively, what is the total sideband power radiated? So we have your PC carrier power, 360 watts, modulated by 2 waves with modulation percentage of 55 and 65. So dalawa. What is the total sideband power radiated? So we need to calculate yung total before we multiply it with your given carrier power para makuha natin yung PT. Tama? Total sideband sideband power radiated. The total sideband power radiated. So M squared for PC. Sagot din naman yung mga EE dyan. Kaya ba mga EE? Yung masyado nang bibilisan? Mayroon pa rin naman kayong principle of comms, di ba? Mayroon pa rin kayong elective wherein you had principle of communications. Wala ata si Mr. Villanueva. Meron ba? Ba't wala si Villanueva? Wala si RL. Sa mga EE. Ang dami din wala sa ECE. Si Glenn. Guys, hindi na to. Meron naman si Glenn. Sino wala sa ECE? 15. 7. Si Villanueva lang ata wala. Tama. Sa EE. 7 kayo sa EE. Siyam sa ECE. Supposed to be 16. So, meron isang wala. Ano na?
490, sir.
490. The total
Oy.
sideband power. That is M squared PC over 2, ano?
Sideband pala, sir.
Sideband power.
O, di yung kwan lang, sir. Di kasali.
Ayun lang siya.
Sir, 130.
130. Sakto?
0.51.
How about yung iba? Kailangan nyo munang kunin yung total dun sa M. The square root ng 0.55 and 0.65. That would result to ano? 0.85. Tama? And then yun yung gagamitin dito. MA squared PC over 2. So that's 130.5. Ito next. Before we proceed with mga ending topics dito. Until the current of an AM broadcast transmitter modulated to a depth of 40% by an audio signal is 15 amperes, it increases now to 20 as a result of modulation with another audio signal. What is the modulation index from the second signal? 20 of 15, 1 plus m squared over 2. Ano pong sagot? Square root of 1 plus.
So 1.5?
1.5. How about the others? So ano yung unang i-compute dito, guys? Ano yung 40%? That is the first, tama? Tapos nagkaroon ulit ng another modulation index, kaya nga nag-increase na siya sa 20 amperes as a result ng modulation with another audio signal. Their IT there is 20. That's the total current for the amplitude modulated na signal. And then your 15 is your IC. So to solve for the second signal, pag na-solve mo na yung total na modulation index, so the total square root of the total minus now your yung first index, yun naman yung sa my second na signal.
$1.5, sir.
1.5 parehas kayo nakukuha.
Sir.
Paano kinalculate? It's 1.296. How about the others? Ba yung
Ay, 1.18, sir.
1.18. Oh, ikaw, other.
One point 18 din, sir.
Kung saan kayo nagkuhan, ba't may iba bigla? Ano yung unang i-compute dyan?
Yung kwan, yung modulation. In terms of modulation, sir.
Yeah, i-compute natin unang is yung IC. There is already made na modulation at 40% wherein the resulting is 15. So, that i-compute muna natin yung IC. Since unchanged naman lagi yung sa may carrier, so i-compute muna natin yun. And then, saka natin gagamitin yung that IC wherein meron na tayo ng IT which is yung 20. Diba? It's supposed to be 1.296. Okay, first, ano ba sa formula? IT
Ay, mali kami, sir. Kala namin
equals
ay IC
to,
na yung
hindi ba? Kumbaga, antenna current of an AM transmitter modulated. So this is a resulting total then. For the first, kumbaga, we have a 40%. This is already a modulated na signal. So as a result of 15 amperes. So IC times square root, tama, of 1 plus m squared over 2. So, kailangan natin i-compute si IC. Si IT doon, sa umpisa, which is we have 15. And then, we need to compute your IC. Alakat na. O, 1 plus m squared over 2. So ano yung value ni IC? Given na tayo nung M, which is, ito is your 0.4.
14.43, sir.
Okay? Saglit. 0.4 squared. So ito is 14.43. Since given na tayo niyan, so kunin na natin ngayon another ganito pero it increases to 20 amperes. So ibig sabihin dumaan po siya ng another stage and nagkaroon nga ng another modulation index. So as total we have 20. Na-calculate na natin yung IC which is 14.43. Tapos M ulit kino-compute natin dito. So, compute na natin yung M, which is equal now to, so in order to compute for the second signal modulation index, diba ang MT natin, this is actually yung solve natin dyan is yung MT. Diba? MT square root ng, ayan, M1 squared, which is yung 0.4, tapos dito yung M2, ito yung sinesolve na natin yan, si M2 squared. Ano yung value dito?
Sir, 1.36.
1.3 lahat na. 1.36. So 1.36 given and then you have M1 at 0.4. So ano si M2? Ayos lang kayo? Di ba may printcom naman talaga kayo? There you had the subject still. Hindi naman ito natanggal sa curriculum. Tama? Hello.
Yes, sir. Meron po.
Ano na value M2? Bayagan.
1.33, sir.
0.4 squared plus alpha x. $1.33 yung sa iba. How about yung sa iba? It's around 1.296 yung sasagot ko kasi dito.
1.3, sir.
1.3, yeah. It's 1.296 converted to 1.3. Mahaba pa yung sa MT, ano, hindi lang siya saktong 1.36. If you consider kasi all the values
Yes, sir.
later on, pag continuous kayo nagsosolve, so makuha nyo din ito 1.296. Or sige, let's proceed with 1.3. Nakuha. Next. Okay, bandwidth formula for AM. So, if a single carrier modulation, it is the bandwidth is just simply twice the modulating frequency or the highest modulating frequency or yung basta given sa simultaneous modulation. So, twice lang nun. So, yun yung consider natin ng bandwidth. Okay, efficiency can also be calculated or one parameter na very important when it comes with technology in the amplitude modulation or mga AM6 systems. So the total sideband power over the total transmitted power times 100% is the measure of efficiency of that system. Percentage power saving, yung total power minus power of the sideband over the total power times 100%. So efficiency and power saving depends on the type ng transmission, but the total transmitted power is computed on the basis of double sideband full carrier. Later on, the single sideband techniques, more on that. So how many AM broadcast stations can be accommodated in a 100 kilohertz bandwidth if the highest modulating frequency is 5 kilohertz? Ilang AM broadcast stations given tayo ng bandwidth at 100 kilohertz tapos yung modulating frequency is at 5 kilohertz. Ilang stations? So given now yung accommodate ngayon na 100 kilohertz na bandwidth, so ano yung bandwidth ng per modulating frequency, so multiply natin to ng 2, which is we'll get 10, and then doon na natin i-divide or makakuha tayo ng 10 stations. Kuha from that total na kaya-accommodate na bandwidth ng 100 kilohertz is meron tayong tagto 10 kilohertz na bandwidth. So, ayun, naghati-hati sila doon sa given na 100 kilohertz bandwidth. So, we have the 10 stations. Parang gano'n sa kanyo, di ba? Sa internet, kumbaga we have 5 Mbps na bandwidth or yung parang pinaka-speed mo, ilan kayong ko-connect doon. Kaya mabagal minsan pag marami. Tapos binay-maintain niya sana yung minimum speed. So, marami din kayo naghahati-hati sa specific na bandwidth, kaya mabagal. Or pag ilan naman kayo, kaya mabilis. So, here is an AM transmitter functional block diagram. So, ito yung katumbas na system ngayon ng isang AM transmitter. So, your audio frequency, and then AF processing and filtering, may preamplifier, tapos mga Class B power amplifier. So, may modulator, Class B output amplifier going through your antenna. So, dito naman sa mga, dito naman sa part ng, sa may carrier, eto sa part ng sa may modulating signal, and then through the output amplifier, and then high-level modulation, and saka may low-level modulation. So, if you're to analyze, is a high-level transmission, yung powers ng carrier and the modulating signal are being amplified. So, and may mga amplifier before applying them to the modulator stage. So, low-level modulation naman, the powers of the two input signals are not amplified. So the required transmitting power is obtained from the last stage of the transmitter, which is the Class C power amplifier. Pag sa low-level na low-level modulation or low-level transmission. Yung crystal oscillator dito, ayan yung produce nung sa carrier mo, your carrier oscillator, it generates your carrier signal, which is the higher frequency than dun sa modulating frequency or your audio frequency na input, which is a low frequency. Okay, himay-himay natin. Let's see ano yung mga ginagawa nung every component in AM transmitter. So you have your crystal oscillator, provides a stable carrier frequency at low power. And then the buffer amplifier, a low gain, high input impedance amplifier, which isolates yung crystal oscillator to improve its ability. And then Class C, the RF power amplifier, which is the driver, provide enough gain to sufficiently drive yung modulated amplifier. Pag sa RF output amplifier, which is a Class C, term as the modulated amplifier or your radio frequency output amplifier. For the output stage for high-level systems. Linear power amplifier, ito na nag-provide linear power amplification of the amplitude modulated output from the Class C modulated power amplifier and used for low-level modulation. Ano audio frequency processing and filtering, so processed and filtered so as to occupy yung correct bandwidth and compress somewhat to reduce the ratio of maximum to minimum amplitude. Mga pre-amplifiers, it boosts now your audio frequency signal in order to provide enough gain sufficiently to drive yung sa may modulator. How about a modulator? Output is mixed with the carrier to generate the AM signal. So dito nagmi-mix na yung carrier and the with the modulating signal to generate now your amplitude modulating signal, your AM. Kapag titignan mo yung mga balance modulator, as a sign or as a symbol minsan, just like, excuse me, multiplication wherein mixing yung nangyayaring process dun sa mga modulators. Kumbaga dun sa kumbaga yung sa figure minsan sa block diagrams, so may X dun sa mga every balance modulator. AM modulating circuits pag low level modulation and high level modulation. So modulation before the output electrode of the final amplifier, stage of the transmitter. So ginagamit dito mga emitter modulation, yung amplitude ng output signal depends on the amplitude ng input carrier and the voltage gain ng amplifier. Ayan, pag sa high level, mga collector modulator yung ginagamit. Wherein pag sa high level kasi mga medium power or pang high power. Pag emitter, yun nga pang low level power na signal power levels. So pag high level, ang ginagamit naman collector modulator, class C modulator for nonlinear mixing, and the modulating signal is applied directly to the collector. Types ng modulators. So for ginagamit sa mga AM modulators, so we have grid modulated amplifiers. Ito yung RF carrier output can only be about 30 to 33% ang DC input to the modulated stage. Plate modulated amplifier. So ito naman around output power can be as high as 70 to 75% ng DC input of the modulated stage. So the whole beauty ng isang amplifier depends on the ability to control a high current or voltage by the application of a relatively low power control signal applied to any sa mga configuration ng mga modulator amplifiers such as ito. For the ECE, you should more read onto this mga grid and plate modulated amplifiers, and yung pinakamagandang reference is kay Kennedy. Dito siya mas nagdi-discuss. Doon kasi kay Tomas hindi niya at gaano to diniscuss, although ang daming tsutsuburotso doon, pero kay Kennedy mas na-discuss yung technology when it comes to doon sa mga transmitters and amplifiers. Yung sa EC lang yung dapat mag-more onto this, ano. Sa EE naman kasi most of the time konti lang yung lumalabas when it comes to principle of communication, pero more on the computer systems. Different class amplifiers. So you have your class A, class B, class AB, class C, and then class D to D. So to easier understand, you have there the description kung paano yung conduction ng every of this amplifier class. So pag class A 363, pag class B 180, class AB more than 180 degrees, but then less than of 360. Class C less than 180, tas class D to D on-off of nonlinear switching. Yung mga amplifier classes, they represent yung amount ng output signal which varies with the amplifier circuit over one cycle of operation. Kaya ito lang yung sa mga conduction. It's better to describe it with the conduction limits. Lastly, pag sinabi natin coefficient of modulation, yung amount lang na amplitude change present in an AM waveform, tapos up converter to translate yung low frequency intelligent signals to radio frequency signals that can be efficiently radiated by an antenna. Tapos trapezoidal pattern used for observing yung modulation characteristics ng AM transmitters. Yeah. Isa kasi pwede minsan na representation, kaya yan, meron yung sa trapezoidal pattern. So trapezoid nga siya. Parang this represents now your maximum and then your minimum, mga voltages or currents. So parang dito niya i-observe yung VMVC. So para mas malaki nga yung sa part or yung sa side. So parang doon nagre-represent din. So trapezoidal pattern. Modulation characteristics. Kung sa calculation yun kapag ganun yung binigay na figure.